My name is Ethan Mills. I'm a tech lead with Softwire.
My name's Wendi. I'm a senior developer with Softwire.
We have been, so the stuff that I'm about to talk about is to do with our work with Channel 5. We've been working with Channel 5 for quite a number of years now. We've built out players for them across all of their supported platforms. We do CMS bits and pieces for them and a bit of work on their content processing pipelines as well, which kind of covers all of the things that we're going to talk about today. Now, it sometimes seems to me like the connected TV space and video playback in general moves in kind of bursts. Sometimes there's loads and loads of new exciting developments, but also like loads of the technical jargon and to some extent the design language of video playback dates back to VHS players. But some of the a couple of years ago, we had a bit of a generational leap in the requirements at Channel 5, both in terms of like technical video playback, but also the UX experience kind of expectations. And these were driven by requirements from platforms, device manufacturers, things like that. So we had to comply with them to stay on devices. So the first one came from UView, who were releasing a new family of devices. This may be a familiar story to people, but they needed content in a new format for on-demand viewing. So they needed a new version of HBB-TV Dash, which we did not support. So we launched a project which ended up being called Project Zeus to try and kind of backfill all of our content into the new HBB-TV Dash and then process that on an ongoing basis as well. On the face of it, it seems like quite a simple thing to do. You go into your kind of commodity video processing software, tick the HBB-TV Dash box and like pat yourself on the back for a job well done. But obviously it's not quite that simple. And the reason for that is Channel 5 don't have easy access to the masters of the content in the later stages of the video processing pipeline, especially for the older content as well. A little bit of context on why that is, because that seems slightly unusual. So we stream in a variety of different formats, but they all work in roughly the same way, right? You've got a big video file that they're all designed to work in roughly the same way. You've got a big video file that you optionally encrypt for some DRM, and then you stick it on a media server or behind a media-capable CDN, and the client requests little fragments of the video, and you serve them on demand for like variable bitrate and progressive streaming and things like that. Now, when the content processing pipeline was first designed, the CDNs in place were not media capable. They were not smart. They were very dumb HTTP CDNs. So the content processing pipeline was designed to split everything up beforehand. And so you can just serve the fragments as individual files. So this is kind of what our storage looks like. You've got a manifest that describes metadata about the video, and then a whole load of video fragments that are all encrypted. And taking that and turning it into a new media format is not an easy thing to do. But you know, there's no new problems under the sun. Let's do a bit of Googling and figure out someone must have done this before. And it turns out that if they haven't put it on the internet. And if you think about it, that kind of makes sense. This is a problem that two groups of people are likely to have. Either big content distributors who stream a lot of content, but most of those probably have access to the originals, the masters, and don't need to mess around with this stuff. Or pirates who are trying to steal the video and put it all back together and keep it, and they haven't put anything on the internet either. So there was time to, the format that we looked into was something called Microsoft Smooth Streaming, encrypted with PlayReady DRM. So time to go learn some more about the details of smooth streaming and work out how to turn this back into a single file. Now, Microsoft Smooth Streaming was a really big thing for Microsoft back in about 2010. And their big vision was that it was going to be Silverlight and IIS 7. And since then, they've become less keen on smooth streaming, and all of the documentation has gone away. So a little bit more research, and it turns out that smooth streaming is very, very similar to standard MPEG Dash, and there is plenty of documentation available about mpeg dash. In fact, about the specification is about 330 pages of dense technical detail, and unfortunately, almost all of those pages are relevant to the work that we were trying to do. So what followed was about 2 weeks of very heavy reading and lots of time in a hex editor, kind of comparing before and after video files and learning about how all of this works. And what we figured out was that the audio and video fragments are basically identical between the files that we've got on disk that we have access to and the stitched back together file that we're trying to get to. So like if you just take all of those files, concatenate them together into one big file, you end up with 95% of the right video file. But 95% isn't enough. So what's missing out of that is the metadata. So that manifest file that we mentioned, we've got big XML file that talks about the format information, encryption for the DRM, so things like initialization vectors, which renditions are present, so what quality levels, segment size, physical location, all of those sorts of things that's critical to actually understanding this at a machine level. So how can we turn this big XML file into a compact binary header for an MPD file? It turns out that Dash.js does this in the browser when playing back video. I think this is for compatibility, but the outcome of this basically is that there's a load of lovely open source JavaScript that takes the XML file and turns it into almost the right binary representation for the metadata header. So with a bit more kind of fiddling, debugging, lots more time in a hex editor working out what's going right and what's going wrong, we got there, and I have never been quite so happy to see Gordon Ramsay's kitchen nightmare play out successfully in my life. Such a happy moment. So just to recap, we've gone from sliced up video file with lots of encrypted fragments back to stitched together video file which is still encrypted but now has all the right metadata and is understandable by lots and lots of off-the-shelf software that will decrypt it for you, because that is a common problem to have. So we can stick that through an open source tool like Bento 4 and go back to standard nice video files that everything knows how to deal with. And all that's left after that is to kind of pick your favorite colorful AWS services and build a content processing pipeline around that process that takes the broken up files, puts them back together, decrypts them, then splits them back into loads of different renditions, encrypts all of those again, splits them back up, integrates with things like our PlayReady DRM server, our CMS, all of the different bits and pieces. And since we finished this pipeline a couple of years ago, it's processed like 27,000 assets, about 48 terabytes of video, and the pipeline, the wrapper around it, has had some bugs, and we've made some little changes. But fortunately, the core stuff that pieces everything back together and does the interesting video stuff has not needed touching, which is really good news, because I don't want to spend any more time in a hex editor looking at video and debugging errors of this nature. But the other thing that this means is that now we've got access to nice, high-definition, like basically MP4 files of all of our content in an easy-to-work-with way in our content processing pipeline. And that lets us do some other cool stuff.
Thank you, Ethan. Cool. So I'm going to be talking a bit about thumbnails. In particular, we're going to start from talking about trick play. Now, what is trick plays? That term originally comes from how it's used in VHS fast-forwarding effects, where you basically play through your tape a little bit faster, and that lets users navigate through everything their video to see the part that they want to see, and you get the weird, like, fun effect of people walking for quickly. This isn't really possible with kind of modern videos and like how modern coding works. There's a lot of compression. You can't just kind of play it back faster or like rewind it in quite the same way. So what can we do? Well, we still wanted to give some kind of experience like that, because being able to fast forward or rewind is an experience that enhances users' ability to use the TV and navigate through their content. So back in 2019, our first attempt was to say, all right, we can't play it back faster, we'll just kind of show sort of a frame every few seconds so you can kind of see what they're going through. And the most sort of naive way we can do this is say, all right, let's skip them forward by 10 seconds from when they start trick playing, step in again, pause, and so on. And the kind of grand idea is, cool, they'll show an image, and we'll move forward and show an image. That doesn't really happen. That ended up resulting in quite a choppy experience on almost all smart TVs. And instead what you see is a constant buffering icon, because there's only a certain amount of bandwidth on connected TVs. They can't just flash up a bunch of images like that as we wanted. Okay, back to the drawing board. That was kind of mothballed for a while, to be revisited later. So a bit later, an opportunity came. We had our content processing pipeline, as Ethan just talked about, and around in 2021, Roku introduced a hard requirement for players to support mpeg thumbnails. So in this case, we had to start doing something that lets thumbnails be used on anything if we want Channel 5 MiFi stuff to be on Roku. So because this is part of the required user experience, we got back to work thinking about a new approach. And this time, we thought about thumbnail generation. We have this shiny new framework to process content, so what do we do with it? We use something like ffmpeg to process our videos, and then every, say, 10 seconds or so, we take a screen grab, take a still of that part. We save those each into these, I think, 4x4 tiles, and then we also do some mapping so that we know at what point in the video do we want to show which thumbnail. I've got to say, before I started working with this, I thought, wow, thumbnails are so magical. I don't know how they process it on the fly. Once I saw these files, I was like, okay. not really quite as magical as I thought, but effective. So yeah, we save all of these into the formats we needed. So save it to MPD, web VTT. So mpeg we included it in the MPD manifests. On certain platforms, such as Roku, it mostly came out the box, same with JW Player. And for other platforms, we provided the web VTT manifest file. All right, so like I said, mostly the things that, mostly for Roku, we managed to do this out of the box with a little bit of additional styling and logic, but it was fairly straightforward. Similarly, on our video player on web, JW Player, also supported thumbnails out the box. Here, you'd be hovering rather than navigating with the remote, but a similar principle applies. However, as Martin and Taha said, the unique thing about the TV sort of industry is that we need to support devices for a lot longer than many other industries. So, this worked for a lot of devices, a lot of new, more modern technologies, but actually extending this to older devices proved to be quite difficult. And, this is a key feature of the market. We need to do this. And what comes with that? So, as Martin and Taha said, there's a lot of challenges on testing on set-top boxes and connected TVs. We definitely found a lot of challenges developing on them as well. We lose a lot of the kind of modern luxuries we take for granted in web development that I was so used to. So the first thing I came across was the loss of modern styling features. Things that included was no flexbox. And I was like, okay, fine, let's go back a bit. Yep, no grid. Okay, cool, it's fine. Okay, let's go back. No table. Cool, okay. Let's make this feature entirely out of divs. And it took quite a lot of iterations to be working on a really old set-top box and realize each of these things that I'm used to is like, yeah, no, let's do some research into how things used to be done much like ages ago. But cool, we got something that looked all right on web. How does it work on a set-top box or a TV? Nope, there's a lot of issues there as well, because first, we don't have the luxury of dev tools just there to use by default. What this means is, okay, we need some way to try and see what's going wrong, see what's happening when something is not displaying as it should. Yeah, and all these different set-top boxes, they all had different issues. It was not the same kind of issue that we encountered. One of the set-top boxes I worked on only showed one image at a time, just like one image and a bunch of crosses. Don't know. Some of them couldn't crop images, so thumbnails that came in these 4x4 tiles did not get cropped. They just displayed like that on the TV still. One of them just slightly misaligned everything. And it was only until after I came back into the office, this was around the pandemic, and tested on a newer device that I was like, oh, that works, it's fine. I didn't need to spend several days just trying to align it manually. And as you can see in that picture there, on one TV, for some reason, our wrapper just showed on one corner of the TV. Still a mystery. Yeah, so developing on these were really challenging, trying to kind of find a solution that was as applicable to as many devices as possible. We did hit a limit to an extent where, okay, at some point we need to cut our losses and decide these are the things that are sensible to spend as much time developing on and supporting, and to some extent we should say, all right, these are probably a bit too old to support thumbnails. But at the end of the day, we still have a lot more thumbnail support across all our devices. And this came from Roku in 2021 saying, you've got to do this or else we won't let you put your apps on our devices. So yeah, this necessity from a supplier became the driver to adopt and innovate across all of our devices. I got my colleague to pull some stats for me. And I think for Video.js, which is the tech we use on our connected TVs and set-top boxes, we have about 75% of users across those who have access to thumbnails. On web player and the other more modern technologies, I think it's significantly higher. Okay, so what do we learn from this? The visual language of a lot of this software is actually determined by technologies from the past. Trick playing is still a term we use nowadays, even though actually it's not so easy to replicate on how we do modern technology. These kind of pieces of ubiquitous design that I think we'll take for advantage, maybe not so much for people here, actually has a lot of complexity, has a lot of thought being put in to make sure that it happens across all the kind of experiences you may encounter. And actually bring old hardware into the modern day is really hard. And there's only so much you can do at some point, but we gave it a good try. And yeah, I think that's the end of the talk for us. If anyone has any questions, please let us know.